I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it. And that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. This podcast is brought to you by Jarhead Diagnostics. Jarhead Diagnostics manufactures in-house diagnostic equipment and storage solutions, as well as distributes for companies like Pico, ATS, and TopDon. One of my favorite tools that I've bought from Brandon and Jarhead Diag is the case for the U-Scope. If you don't have a U-Scope, you probably should, but if you have one, you got to get one of these 3D printed cases, has a magnet on it, has a full-size BNC lead that you can connect to, and it gets rid of the weak point of that scope, which is the mini BNC connection, which is pretty fragile. This case makes this thing nice and secure and makes it an even better tool than it was. So check out jarheaddiag.com. The link is in the show notes. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. We have got Auto Rescue Tools and Isaac Rodell as a sponsor for this podcast. Hey guys, if you're looking for programming laptops, you want the laptop set up ready to go for programming control modules on vehicles, you need key cutting equipment, you need diagnostic tools, Isaac is your guy. Has all that stuff available for purchase, and the support that he offers along with the purchase has been outstanding. I bought some stuff from him in the past. I got my Dolphin key cutting tool from him several years back. And again, the support has been phenomenal. Helped me out along the way with anything additional I needed to make it work for me. Also, for the month of June 2023, they've got Autel updates for sale. So make sure to check that out as well. Again, that's autorescuetools.com. The link will be in the show notes. Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? This is the Automotive Diagnostic Podcast. My name is Sean Tipping. I will be your host today. Thank you for tuning in. Today, we are going to talk about remote keyless entry, specifically the transmitters. Key fobs is the slang that's used for these. Obviously, these have been around for quite a while, but just about every vehicle that we work on is going to utilize the remote keyless entry function in some manner. I mean, most cars now have a key fob, whether it's for the actual keyless ignition or just to unlock the doors. We're dealing with this on everything. And I've dealt with a couple in the last month or so that were more than just a remote or a battery failure, because honestly, probably about 90% of the issues we see with these is either a remote failure, the actual key fob itself, or it's a low battery. These things just take the little flat 3-volt batteries, and it's as simple as pulling them out and checking the voltage. They should be about 3 volts. That's what we do to fix most of these things, and it's been the case for me. So I've never really dug into this more, but recently I had a couple vehicles. One of them was actually my personal vehicle, but another one was the owner of a shop that I go to for programming was having some issues with his 2019 GMC Yukon. And it was a poor range. And it was actually the same thing with my car. My car just ended up being a remote that was failed. I think I had bought it off Amazon years ago, and it's just a cheap Chinese one that didn't hold up. The battery didn't fix it, but the range was really reduced. And that's easy enough to figure out. Okay, you try another remote and you see that it works. The GMC Yukon wasn't quite so simple, but what these two different vehicles got me thinking about was, number one, I don't really understand what these radio signals are. I've never really taken the time to read into this and understand exactly what's happening. And I don't have any real method of measuring the range of these RKE transmitters. And what I mean by that is I've tested plenty of them to see if the key fobs work. And the way I've done it in the past is either a TPMS tool, the tire pressure sensor systems. The TPMS tool will actually, in most cases, have a function to test key fob output. So you go to this setting, you press a button on the key fob, and you'll see something happen on that tool. And of course, there's other tools out there to measure the output of key fobs. Diagnostic Box has a key tool that works along with testing a fob for keyless entry. You can also test the antennas in the vehicle for keyless ignition. And I actually have a tech tip where I describe that tool, and it's pretty useful. But here's the limitation of these tools, whether it be a TPMS tool or the one I mentioned. You have to be pretty much right on top of that tool with the key fob in order for it to register a signal, at least from what I've found. If you hold that thing a few feet away from the tool and you press the button, it doesn't pick up anything. At least that's what I've experienced. And if you go several feet away, you go across the shop, you're not going to pick up anything on either of those tools. There's no chance. So the problem or the limitation, and there's limitations to every test, of course, that's one of the important things about doing any test on anything is understanding what it can do, but also what it can't do for you. And the limitation to using those tools to test a remote keyless transmitter for unlocking a vehicle or a remote start or whatever, pop in the trunk, setting the alarm, is the range. We can't really test the range. Now, some of these tools will tell you the strength of the signal, but what I'm really curious in these two vehicles that I was working on is the signal actually reaching the vehicle? Okay, I can slowly step back from the vehicle and I can measure the range that the fob will interact with the vehicle. That's easy enough to do. But when there's an issue where you have determined that the range is short, and I would say from doing research and personal experience, the biggest range that you could have for a remote keyless transmitter is about 65 feet. I'm sure there's exceptions to that rule, but generally speaking, that's the most that we can see. If you have determined that the range is short for the transmitter in the vehicle you're working on, and it does not turn out to be the remote that's at fault, what else can we do? How can we measure something? That's really what I was looking for. Is I want to be able to measure something like I would with a voltmeter or a scope and
give a value to something. Say that, yes, the signal's definitely getting to this car, but it's not seeing it for one reason or another. And so that kind of got me going down this rabbit hole. Because like I mentioned, I didn't really understand what I needed to measure. I know that I've seen the frequencies listed on these tools on the back of the fobs and in service information, but I didn't really understand what was happening when you press that button. So what I'm going to go through with you first is just a description of radio frequencies and how all this ties in together, because of course, if we're going to measure something, we need to understand what it is we're measuring. And then going to go through a little bit of the actual diagnosis I did with this Yukon and a tool that it can be useful. I'll get into that, and we can actually see some of these radio waves, these radio frequencies at a distance, at a range. And I think it's pretty cool, actually. So went down a rabbit hole this week, of course, and maybe that's what some of this is going to be, but I find it very interesting. I like learning about this stuff, especially something that I really am not that familiar with how all of it works. So the first question we ask ourselves, or I asked myself anyways this week, was what is a radio wave? Because that's what the transmitter is emitting to communicate with the receiver in the car to do whatever button you pressed, unlock, lock, alarm, trunk, remote start, whatever it is. What is that actual radio wave that's coming out of your key fob and going to the car? And simply put, it's an electromagnetic wave. All right, so that's easy enough. But what is an electromagnetic wave? And that's not an easy thing to answer. At least I didn't find it easy to answer. And the reason it's not simple to explain what an electromagnetic wave is that you have to get into electric fields and magnetic fields, I think, to really understand exactly what's happening with an electromagnetic wave. And of course, once you get into the theory behind electric field and magnetic field, how they interact, we can measure some of this stuff, but the theory can leave you with more questions than answers. So I'm going to put it very simply, what an electromagnetic wave is, but understand that there's a lot more behind this. And I'm not going to go too deep into the actual electromagnetic wave or what it is. Number one, that's a big discussion. That could be an entire episode. Number two, I'm probably not equipped to have that discussion by myself. I've got a limited grasp on what's actually happening there. And number three, we kind of want to keep everything practical. How does that actually help me fix the car? And that's what this podcast is about. Of course, we want to learn new things, but how do we actually apply this to our day-to-day job and figuring out the problem? So with that being said, electromagnetic wave is just an oscillating wave that propagates through space. And we're kind of going to leave it at that. There's more to it. There's way more to it. And it's pretty complex and very interesting. And I'll tell you what, I'm actually going to put some links in the show notes to a podcast that Hans Jorgensen turned me on to. It's got some really good information on this stuff. And there's some YouTube videos that I will put in the show notes as well. Really, really interesting stuff. But again, that's a whole topic on what an electromagnetic wave actually is. But it is an oscillating wave that propagates through space. Okay. Think of like a sound wave or a wave moving through water. Similar in the concept. We can wrap our minds around these things. At least, a wave in water, we've seen it, we understand what that is. We can pretty well understand and measure sound waves. That's, the vibrations moving through the air created by our vocal cords or whatever's making noise, right? And an electromagnetic wave is going to be similar in the concept, but it's different in what it actually is. And these can be emitted through space, where there is no matter to vibrate. They don't need a medium like water or air, like sound or waves in the water do. They can move through space. And they're going to oscillate. It's going to be a wave, but it's just moving through space. Now, and this is the other thing, is they can actually move through physical matter too without being changed. And there's some variation there, of course, depends on the strength and the frequency of the wave and what the actual matter consists of. But if we think of like a radio wave, like we're talking about with our keyless entry transmitters, they can actually move through a wall or through the body of the vehicle in order to, get to the receiver. And that is something to understand about these electromagnetic waves, is they don't stop when they hit a wall or any type of matter. They can actually move through it and continue on. So where do these electromagnetic waves come from? There is a lot of different sources. I could pretty much say that almost everything on this planet is emitting some type of electromagnetic wave in some way, and that would be probably fairly accurate. But again, I have a loose understanding. I just did a lot of reading this week on this stuff, but there's a lot of different types. Maybe I shouldn't say different types. There's a lot of different frequencies of these electromagnetic waves that we interact with on a daily basis all the time. This stuff's all around us. But one of the important things to understand about these waves is that they are oscillating. I mentioned the frequency. And that frequency of the oscillation of the up and down, think a sine wave, an analog signal, up and down, up and down. The frequency, how fast these electromagnetic waves actually do oscillate, changes what they do and what they mean to us as far as humans and technicians. The frequency of this wave is going to change what it does for us or means to us. And that's how we actually measure these waves or wavelengths, is going to be in frequency, and we use the unit of Hertz. And this comes from Hendrik Hertz, was a German physicist he was the first person to conclusively prove the existence of these electromagnetic waves. Although they had been theorized prior to that, he was actually able to, put some concrete measurement to these waves. And in his honor, they use the measurement Hertz to measure the frequency of these electromagnetic waves, how fast they actually oscillate. They switch from, one polarity to another, if you want to consider it that. When I think of Hertz, I think back to high school, and you'd go up to your buddy and say, "Hey, do you want a Hertz donut?" And your buddy's like, "What's a Hertz donut?" And then you punch him in the arm and you say, "Hertz donut." And so anyways, that has nothing to do with what we're talking about, but just what I usually think of when I hear Hertz. But Hertz is the frequency, but it's measured in cycles per second. And you'll see this in scan tool and other measurements, but we see it with radio frequencies and these electromagnetic waves. And again, it is how quickly it is going to oscillate, how many cycles, how many times that it is actually going to oscillate per second. And that's our unit of measurement that we're going to use. What I don't want you to confuse this frequency with, or the speed of the oscillation, is the speed of the actual wave, though. These electromagnetic waves, when they're created from whatever source that it is, and I'm going to go through a few of those with you to get you an idea, but no matter the source and no matter the frequency, they all move at the same speed through space. And that is actually very close to the speed of light. Of course, there's some variations here depending on where you're at, what matter is present, but to put it simply, once these waves are emitted from whatever source they are emitted from, they are going to move at the speed of light. So no sooner do you hit the button in your key fob with your little 3-volt battery, do these electromagnetic waves reach their target, which is your vehicle. They might say, well, how come I can be 80 feet away and it doesn't get there? Shouldn't the speed of light be able to get that radio signal to that point? Well, the strength of the field plays a role in how it can be picked up. That is going to play a role in the distance, but these waves will travel through space at the speed of light, which is pretty crazy. But back to the frequency, how quickly they oscillate. They all move at the same speed, but they're going to oscillate at different speeds, and that changes, again, what they do for us, what they mean for us. So in order to understand this, we want to look at what's called the electromagnetic spectrum. And this is going to show us, you could just Google this, but I'm going to go through a few key points in the spectrum, but it's basically just a chart that shows you at what frequency these waves oscillate and what they are to us, in our lives on the planet Earth, how we actually perceive and interact with these different frequencies. But they're all the same thing. If we just break it down to its simplest sense, it's all electromagnetic waves just oscillating at different frequencies. So let's start at the top end of the scale, the fastest frequency that we're able to measure, and this is going to be gamma rays and X-rays. And so you're probably familiar with X-rays. They're used, to get basically a picture of your teeth at the dentist, or if you break your leg or your arm, the doctor can use an X-ray in order to see inside of your body. But again, these are electromagnetic waves. They're oscillating at an extremely fast frequency. When we're talking up in this range of X-ray and gamma ray, this is quadrillion to quintillion times per second, which a quintillion is 18 zeros. If you're unfamiliar with how big of a number that is, that's moving, it's changing, from one polarity to another, and maybe polarity is not the right word to use here, but it's oscillating that many times per second, which is just crazy to even comprehend. 18 zeros, but that's how fast these are moving at the top end of the scale. If we move down the scale, the next up is ultraviolet light. So this is light produced by the sun. Some of it's blocked by the atmosphere, but that's why we have to wear sunblock when we're outside, because this ultraviolet light is at a still very fast frequency. They put this into petahertz is the term, and again, that's up in the quadrillion range of cycles per second. But this is a form of that electromagnetic wave that's going to be moving very fast, and obviously can damage our skin. That's one of the causes of skin cancer, is ultraviolet light. If we slow it down a little bit more, it is what all of us are very familiar with, is light. And obviously, if it's dark out and you're in the middle of the woods, there's going to be some light coming from something. I mean, even the stars you'd see in the sky at night, but the sun, a flashlight, a fire, anything that's producing light, that actually is an electromagnetic wave, but it's oscillating at a frequency that we can actually perceive with our eyes. Our eyes have evolved to be responsive to electromagnetic waves within that frequency of the spectrum. So that's everywhere from violet to red, all the colors in between. We can see those, and they help us do everything that we do. Obviously, we need light in order to do just about anything. So everyone's experienced that. If we keep moving down the scale, after visible light, it's going to be infrared light. And so infrared light is actually given off by anything that produces heat, including our bodies. Our bodies are giving off infrared light. So if you look at a thermal imager or night vision goggles, they're actually receptive to the infrared light, which is electromagnetic waves moving at this frequency. So next time you pull out your thermal imager, realize that it is picking up these electromagnetic waves. And it's kind of weird to think too, our bodies are actually giving off this radiation, these waves, which is interesting to think about in itself. We keep moving down the scale, and I am getting to a specific point. Microwaves is the next thing that most of us are familiar with. And as far as the speed here, we're still in billions of cycles per second. So these things are still oscillating very fast. But of course, a microwave you've probably used to cook your food in. It is actually going to induce heat through these vibrations in whatever you're cooking. So you can microwave your pizza and it's nice and hot for you real quick. Within this range, and some of these can kind of overlap with each other, is also radar, which again, we are familiar with as technicians. This is used in a lot of ADAS systems. And you probably have heard the term millimeter wave radar used for many of these ADAS systems. Well, this refers to the actual distance traveled between oscillations. And they can actually give that a measurement because the speed of these waves are constant, which is the speed of light again. So it's how far did this wave travel within those two oscillations, and they can make that calculation, and it's within millimeters, so they call this millimeter wave radar. But again, this is going to be used in our ADAS systems, and there's some other things as well. Now, finally, we get down to some of the slower frequencies that we're talking about today, which is radio frequencies. And these can have a pretty big range. And again, there's some overlapping here, but we're talking about gigahertz down to kilohertz. So that's thousands of cycles per second. Megahertz, which we'll use that term, is going to be millions of cycles per second. And gigahertz is going to be billions of cycles per second. So still incredibly fast as far as how quickly these things are changing, but they mean different things to us. So within this range of radio waves, this is really everything like Wi-Fi, like Bluetooth. Bluetooth, I found out recently reading, is 2.4 gigahertz. That is its frequency, and there's a range within there that it works with. But a Bluetooth device is just a short range radio wave, really, for two devices to communicate with each other. Television, at least broadcast television, is going to be within this range. Cell phones, TPMS sensors, as we start applying this to vehicles. And of course, everybody's familiar with AM and FM radio. Of course, this is at the lower end of the frequency spectrum as well. But finally, getting to what we're actually talking about is remote keyless entry, or the actual transmitters, the key fobs that we're talking about. So these are going to work on one of, I say, two frequencies. There are other examples, but the most common frequencies that we deal with for these transmitters is about 315 megahertz or 433 megahertz. And it'll depend on the vehicle and where the remote came from, which frequency it's going to work with. But in North America, those are the ones we see. I know there are some remotes that'll work in a 900 megahertz range if they have remote start, but I haven't seen too many of those. But for the most part, again, what we're dealing with is 315 or 433 for a remote keyless transmitter. And again, that's megahertz, which is millions of cycles per second. So when you hit that button on the key fob, it's going to send out this pulse, again, at the speed of light. This little 3-volt battery and the little transmitter is going to send out these waves at the speed of light towards, well, it's going to go in all directions, but it is also going to go towards your vehicle. Of course, you don't have to point the remote right at the vehicle. It will help with range, but you could point away from the vehicle. And of course, the radio waves are going to hit it. It's going to receive it as well. Now, most of the transmitters, when we do this, when we hit the button, it's going to work within this frequency. So you might ask, well, if everybody's remote is working on the same frequency, and I know I mentioned 2, but let's just take 315. If I had 2 transmitters that are both working at a 315 megahertz frequency, how do the vehicles not get confused as to which transmitter is which? Well, within this, that 315 is really just a carrier frequency. Within that, it can actually modulate the amplitude. So this would be like AM and FM radio. AM is amplitude modulation, FM is frequency modulation, but the keyless transmitter, at least again in North America anyways, is going to use an amplitude modulation within that frequency. So what it's really doing is it's sending out a specific frequency, again 315, but is changing the strength of the field, the amplitude of the waveform slightly in order to relay whatever message needs to be sent. Now, again, this could be lock, unlock, alarm, trunk, remote start, but along with that, there needs to be some sort of identification to say, hey, I belong to this vehicle. Of course, that's when you program in a key fob to a car, you're learning the BCM or whatever control module is in charge of that this key fob belongs to this vehicle. So when we see this code, okay, it's okay to unlock the doors. Newer stuff is also going to use a rolling code within that so that it's never really the same information. So somebody couldn't, be able to detect that signal and then copy it. It's going to change every time. There's some sort of calculation that it uses to figure that out. And when we get into advanced systems that have, passive entry where you push the button on the door handle and it unlocks the doors, there's actually communication back and forth between the key and the car. It's a two-way communication. But that's getting into the keyless ignition stuff, which I have kind of covered in other podcast episodes, but really not my focus here today. The antennas in the vehicle for keyless ignition are going to use a much lower frequency, and there's different ways to detect it. Same idea, but we're going to stick with just the remote keyless entry at this point. That's my main focus here today. So back to the range on these things. Again, just a 3-volt battery in most of these, so you get at max about 65 feet. Some vehicles are definitely going to be less, even when everything's working correctly, but that's kind of the maximum range for a lot of these. Now, obviously there's going to be a lot that can affect that as far as what obstacles are in between you and the vehicle. And again, strength of the battery makes a big difference. And that's usually what fixes these things, is a new battery that is going to, amplify that signal just that much more so you can get the range out of it that you want. So hopefully I explained how that works enough for you to understand. Maybe I went a little too far, but I just find that stuff pretty interesting, that these radio waves or electromagnetic waves are all around us. Pretty much everything we do, everything we see is affected by these in some way. But let's apply this to an actual vehicle and a little bit of a case study here. I say a little bit just because I don't actually have the final confirmation on this one just yet. I will eventually, but I think we made some good progress. And of course, understanding how all this works definitely helps in order to diagnose these problems. And again, this would be an example of where the remote's good. Of course, you can try a known good remote. The battery's been changed, and we are still experiencing issues with the range of one of these remotes. So this is a 2019 GMC Yukon. And he was having some trouble. Again, this was the owner of a shop that I go to on a regular basis. He was having some trouble with the range of the remote. And it was intermittent, but consistent enough to be kind of a nuisance. He wanted to use the remote start at times, or just obviously locking, unlocking the vehicles. And again, intermittently, he'd have to be very close to this vehicle. And of course, he bought this thing new, so he knows what the range should be. And his girlfriend has the same truck. So even if he was not sure about the distance away from this truck, they can try it with the other truck and, compare the two to say, okay, well, this one works from this range. And, my truck has this shortened range. I have to be this much closer to the truck in order for it to see and respond to that key fob. Of course, he tried batteries, tried a remote, the basics, didn't change anything. So, of course, I verified the voltage in the battery. It's like, well, maybe you just got a bad battery. It's 3 volts. It's good. And then I also checked the range, and again, in comparison to this other truck. And that's kind of nice. I had a known good right there. So I had the 2 remotes in my hand, and I just walked backwards from the vehicle out in the parking lot until the problem truck would not respond to the key fob button. Of course, you could see the taillights flashing when you were pressing the button. And the distance between the two was about 40 feet. And so this is pretty much the same vehicle, the same remote, and 40 feet of distance. I could step back 40 feet more on the known good than I could on the truck with a problem. So at least I have a distance now that I can measure. And again, this is 40 feet additional to where the problem truck stops working. And just like he'd said, every once in a while, you could get it to work from a farther range, but it was kind of intermittent, and there was definitely a noticeable point where it became more difficult for the vehicle to respond to this key fob. So I wanted to know, of course, what is actually receiving the radio frequency, the signal from this key fob in the truck. And the way this works is there is an actual remote door lock receiver. It's just a unit in the right rear of the truck, and it is meant to pick up these signals and send it to the BCM so the BCM can do what it needs to, lock, unlock, the rear hatch would open, remote start, whatever needs to happen there. And connected to that receiver is an antenna with an amplifier. And the antenna is just built into the right rear window. You can actually see it there. It goes up to the roof underneath the headliner, comes down with a cable to this receiver. And there's an amplifier built into the top of that antenna to strengthen the signal for this receiver. And so I was looking at these components and utilizing the scan tool and looking at the remote door lock receiver, I could see that when I moved outside of that range, it didn't see me press the button. You know, we had 2 people working on this, and the response in the scan tool showed that, you know, the button's being pressed, but the vehicle's not seeing it. And I think, you know, we could have guessed that, but I wanted to see in scan data to see what was happening. Was it refusing the signal for some reason or another? No, it just didn't see you pressing the button at that time. So I was questioning the antenna and this amplifier to see maybe these are affected somehow and the range is reduced because of those. And so I wanted to do something to test it. And it's kind of tough to do because I don't really know how do I test these to make sure they're working. And what I tried was I unplugged the antenna from the receiver, and then I checked the range. It was significantly reduced after I did this. So I know they're doing something. Now, are they working as well as they're supposed to? That's kind of tough to say, and it's not like you can just pop this antenna off and try a different one. It's built into the window of the truck. But they are doing something because it affects the range once I unplug it. You have to be pretty close to this vehicle if that antenna is not plugged into the receiver. But that also helps me to say that there's not a connection issue between the antenna and the receiver. You know, this it's almost like a coax cable that goes between the two. And I've seen where those can have a disconnection, at least with the antenna for the radio, and you won't get a signal. But this seems to be making good contact between the two. So at this point, I don't really have a whole lot to go on. So I'm going to do some research and I'm going to look to see if there's any known problems. And of course, you know, it's a good thing to do, check for service bulletins and see, has anybody else dealt with this sort of issue? Of course, it's a 2019, but I actually did find a service bulletin. The service bulletin covers trucks like this going back a few years to, I think it was 16, 17. And what the bulletin talks about is, of course, poor range for the RKE transmitters, or, you know, just not working at all. And what it listed as the issues, what you're supposed to check for, is aftermarket Bluetooth and LED devices on these trucks. And what it says in the service bulletin is that these devices will interfere with the vehicle's ability to respond or see the radio signal put out by your remote, your key fob, that these devices will interfere somehow. Now, it doesn't go into explanation as to how this happens, but it says that there are multiple cases where removing or disconnecting these Bluetooth or LED devices will restore the ability of the vehicle to see that key fob button being pressed. So of course, that's generally speaking easy enough to see if anything aftermarket has been added to this truck. And to be totally honest, if I didn't have a known good sitting next to this truck, maybe I wouldn't have been able to recognize it. Of course, I talked to the owner and I knew this from talking to him as well. But the taillights and the headlights in this truck were aftermarket LED taillights and headlights. And so after reading this service bulletin, I'm wondering, okay, and I asked him, was there anything else aftermarket? And there wasn't. And of course, asked him, did this start happening after you put these in? Because he put them in himself. And it wasn't immediately after he put them in, but it's since they've been installed, of course. So what I want to do here is unplug the taillights. And I just started with the taillights because the receiver is actually very close in proximity to the right rear tail light. So unplug these and then retest the range for this remote keyless transmitter. After I did that, I was able to get within a few feet of the known good. So you might be asking, well, how does this work if the taillights are off? Shouldn't the signal be able to get there until they turn on? Well, what I found was most of the time when there was limited range, it was on the second key fob press. Didn't seem to be that way every single time, but there was a pattern. But either way, once I disconnected those LED taillights, I was able to get a significantly more distance away from the truck and get it to respond to the key fob button. So I think it's safe to say in this case that these taillights, these LED strips that are built into these taillights, are interfering with the truck's ability to see the signal. And of course, I was asking myself after this, I told him about this and he's like, okay, we'll see if we can find, some other ones, and then we'll retest at that point and see what difference it makes. But I was asking myself, what is an LED doing that it's interfering with a radio signal? And of course, this is where I dove into researching what is a radio signal, how do these things interact with each other. And of course, the LEDs are giving off light, which we said is an electromagnetic wave, but that's in terahertz, trillions of cycles per second. It's a different frequency. After researching this a little bit, it's kind of a known problem that LEDs can interfere with radio signals, and they'll interfere with garage door openers, but also keyless entry transmitters. And it's not the LED itself, but the driver circuits that are used to actually operate these LEDs can oscillate at a frequency that interferes with radio signals. Okay, so my next question is, how can I measure something like this? I want to actually be able to have a test to see, is there interference happening? And in that GM service bulletin I mentioned, they do list a tool to measure for this. It's discontinued. Of course, I couldn't find one, but I was looking at some other tools that were available. And actually, I got to give credit to a couple people, Mitch Minton and Chris Groff on Facebook. Mitch posted a tool that's used to actually detect RF signals. And then Chris tagged me in it, and it's only $40, and you can order it off of Amazon. It's a SDR dongle, and it comes with an antenna. And so $40, order it from Amazon, download a free software onto your computer, plug this thing in, and it is going to give you a visual representation of radio signals, and you can type in whatever frequency you're looking for. And of course, it's got limits on both ends of the scale, but for what we're working with, as far as radio signals, this thing can pick up and show you in a waveform on the screen pretty much any signal, from kilohertz to gigahertz. And here's the cool thing about it. It comes with a big antenna. And so I bought this thing and I've been messing around with it. You can see and actually hear. You could pick up radio stations if you want. Of course, you don't need this tool to do that, but you can see and hear as you press the key fob buttons. Set it to 315 megahertz and press the button on the key fob and you can see the response. Okay, well, that's cool. I can do that with my TPMS tool as well. Well, of course, this is cheaper than a TPMS tool, but here's where this tool comes in handy is that I can test it at a range. And this is an ability that I haven't had before. So I can go the 60 feet away from a vehicle and press the key fob, and with the antenna extended on this tool, it will actually pick up the signal. Now, the signal's weak, but you can see, did it reach this vehicle? Is the key fob able to get the signal to reach the car? And so this allows me to test these at a range, which is, again, something I haven't been able to do before. But my other question was, can this detect any sort of interference that's happening within the vehicle from, let's say, an aftermarket LED strip? Well, I messed around with it for about an hour or so on this vehicle. This shop owner let me go back and just kind of play around with this thing, because I'm really just experimenting and learning this thing at the moment. It's kind of new to me to look at these different signals, and I can honestly say that I wasn't able to see anything that I could definitely say is interference. You still got those aftermarket LED taillights in, and I tried some different things and some different ranges and disconnecting something, and I can't really say that I definitively saw anything. Not enough to be able to make a diagnosis and say, yes, there's interference in this vehicle. But I think this tool has some potential, and maybe somebody who understands this stuff a little better, or maybe if I keep messing around with this and do some learning about it, I think it has the potential to detect something like this. Maybe not. It's totally possible that it's not usable for this tool. Again, we want to know the limitations of our testing methods. But either way, for $40, this is honestly the most accurate tool that I've ever used to visualize signals from any sort of RKE transmitter. And whatever the frequency, you can see it. You could use this for tire pressure sensors too. They're going to be in that same range of frequencies. And there's a number of other things. You could check for Wi-Fi or Bluetooth signals if you set it to the right frequency. And it gives you a really nice output. I'll put a picture or a video in the Facebook group, and I'll also put the link to this tool off Amazon, because again, it's $40 as long as you got a laptop. I mean, this is cheaper than any other spectrum and analyzer that I've found, and it's pretty high quality as far as what you're seeing on there. So anyways, I've got more learning to do with this tool, and I'm going to continue to do it, but I want to share it with all of you guys because, number one, there might be I know there's somebody out there who knows more about this stuff than I do. Hit me up. I'd love to have you on the show. Teach me a thing or two. But I'm going to continue learning by myself, and, just one more tool. Of course, that's... We're always after that next tool that allows us insight into something that we couldn't otherwise see or measure or perceive. So in that aspect, I think it's worth it. I think it's worth that $40. So hopefully you enjoyed this. Hopefully you learned something. Hopefully I didn't ramble on too long about electromagnetic waves, but I like all that stuff. I'm a nerd for the science of things. So other than that, let's get out there and start fixing the world one car at a time.